With this one, we want to revolve this around the y-axis. So we're going to be revolving this around the y-axis. So essentially, if we actually drew it, well, tried to draw it, since I'm so amazing at this, it's going to look something like, well, you're going to have this other piece right over here, and then it's going to look something like this cone-ish looking thing. So if I take this one piece right here, and I take this cross section right here, and I actually pull that out, and actually analyze just that cross section, it's actually going to be a circle with kind of a depth to it. And this circle, if I look straight onto it, is going to look something like this. And my radius here is going to be my actual function. So my radius here is going to be the tangent of pi over 4y. And then, so the volume of this little teeny tiny piece is going to be pi r squared, and r is going to be tangent of pi over 4y, and that's going to be squared. So this is pi r squared, and then multiplied by this kind of change in y, because that does have a thickness to it. So it's going to be multiplied by the change in y. And if I add every single one of these circles up, you're going to end up getting an integral from 0 to 1. And then the pi can get pulled out. And then I end up getting the tangent squared of pi over 4 y, and then dy, delta y becomes dy because it's getting infinitely small. This little piece is going to get infinitely small. So another big reason why I wanted to do this video is to make sure you know how to integrate this. You're going to have to use a trig identity. And the trig identity you're going to be using is the tangent squared of x is the same thing as secant squared of x minus 1. So I'm going to use that on this. So I end up getting pi integral from 0 to 1 of the secant squared of x minus 1 dy. Oh, and it's not x. It's not x. This is pi force y. And so if I integrate this, I end up getting the integral of this, which is going to be the tangent of pi over 4 y divided by the derivative of the inside, because it's linear, 4 over pi, and all of this is getting multiplied by pi. And then I end up getting minus the derivative of 1, which is y. Sorry, this is so squished. And that's evaluated from 0 to 1. Now, if I evaluate this from 0 to 1, well, I'm going to distribute pi in, so I end up getting 4 tangent of pi force y minus y pi evaluated from 0 to 1. Now, if I plug in a 1, the tangent of pi force the tangent of pi force is going to be 1. Now, if I plug in 1, we're going to get the tangent of pi force, which is 1. So then we're going to get 4 minus, plug in a 1 here, I'm going to get pi. And then if I plug in a 0 into tangent, so the tangent of 0 is 0, and then this is going to be 0, so that's it. We're done.